All right. So, lights, camera, action. Okay, so, new week, new topic. We're going to start talking about scripting, and to have something to script, we're going to start doing physics. That's the main topic for this week. You can see in the syllabus, I do intend to more or less stick to that sequence of topics, kind of going through. And again, there's no textbook here, and I'm not assigning readings, but just so you know, I mean, I brought this up before, but there is a manual. I'm going to bring it up to keep me honest now and again. And so if you want to be reading ahead and you want to kind of see it out of the horse's mouth, more or less, see, here we go, physics and scripting. We'll start doing that in the opposite order. Here we go, scripting. All right, so some very, very basic stuff. I got a few cheater notes here to get me started. Actually, the very first thing should be there is an example file, so you might want to start that downloading. It's not big. In Sakai, scripting and physics in the title. Download that, get it unpacked. That's what I have up here. What I would like to try to do, because our schedule is so weird this week, and we're so back-loaded with our time at the end of the week, it's not my favorite way to do things, is to try to jam everything in before the weekend. So I think maybe the best we can do with that, given the schedule, is that I would try to do maybe a fast once over everything on a Monday. So if you need to get work done for this class Monday, Tuesday, you can get going, okay? And then maybe it'll probably be a little fast, then maybe I'll swing back around and we'll go into some more detail, Wednesday, Thursday, and then of course lab check on Friday. And you know what the assignment is for this week. It's up in Sakai. Okay, the next week, guess what? It'll be a bunch of scripting and physics related stuff. Okay? All right. Let's talk about some code. So the first thing I have here, once you get this up, you see there's a bunch of scenes here. Double click on number 1. And if I actually run it, I believe there's a comment there. I don't know why the camera's in such a weird place. Read script on Sphere, run an open console. Okay, so you guys know enough at this point probably to guess what that read script on Sphere means. So scripts are attached to objects, generally speaking. Okay, they don't absolutely have to be, but they typically are. So let's go. I'd like to have some code open in front of us to kind of remind me of what I should be talking about. Now, you guys are in a good position to be able to understand as much of C# as you feel you need to know. I'm not pushing learning the language just for learning the language. It's actually, in fact, very similar to Java under the hood, but of course, it is a whole other language. It's a big system. There's plenty of people earning their living as C# programmers, lots of libraries, and no end of stuff to know. If you like it and you want to do it for the rest of your life, it will be quite engaging for you, and you'll never finish learning every nook and cranny. Okay? The basic stuff you kind of know. So it's a Java type language, so it's strongly typed. All right, so you're over the shock of, I put this field in my object. How come I'm not? It says there's some kind of violation. I can't access the X property in the object. Yeah, okay, make it public. So play with it. Play with the protection, so you know what those issues are. Now, here is a specific script. So let's get oriented with that. It is I have no idea actually what it is. Let's work out from the sphere. I said it was on the sphere, so if we look over here and I click on the sphere, we see that, okay, here is the script. Okay, and you can click on here and say edit script, and there is the sphere script. Okay? All right, so what's it doing? All right, so that's always nice to see what the script is actually doing. When we get started, so let's open up the console window. So Control-Shift-C does that if that's news to you. And I can clear it out here. You see it automatically is set to clear on play. And I can press play. And some words come out. What does it say? In awake. Okay, it's giving me a timestamp. It's giving me a message that I wrote. You'll see that in the code in a minute. And then some other information about how the message got generated, which I don't find fantastically useful. Okay. In start, I, the sphere, am at block coordinates. The cube is at block coordinates. In update. Now you'll notice over here, and this is a new thing, and I think I do like it overall, but it takes some getting used to. When you send the exact same message to the console more than one time, instead of putting a new line down, it increments a counter on the side. Now this takes some getting used to, because if I put some other stuff down here, hi, my name's Chris, hello world, okay, and then I do another in update message in my code, that's what I'm trying to indicate, your time is flowing by, you would expect the new in update to be down here as a new line. It won't be. It will go back up to the top, finds the old one, and it will increment that counter one more time. Okay? So what I'm saying is the last thing at the bottom is not necessarily the last message to be printed. In this case it is, but it won't necessarily be. Okay. All right, so let's take a look at the structure of this script. Now I created this script the way that you probably have done it many times in the tutorials already. Now if you go over here and say add component, okay, and then scroll to the bottom and say new script, and then give it some name, my new script, and then say create an ad. Okay, that's how I built it. Okay, and here is the new one isn't being shown. So let's look at the new one first, because you know what? That's going to be way easier than the one that actually does something. This is what you get. Okay, so you see they're kind of steering you down a particular path. Okay, this is the typical method, right? So this might be the only method you've seen if your whole experience is in the tutorials. You have a game object that's already there, and then you come and you add a component to the game object, many different kinds of components, but one kind is a script, and then it pops this up, and you see it wants you to make a new class. It needs, so as with Java, the class name needs to match the file name. Okay, so again, another hurdle you're probably well over. You notice the colon there, colon mono behavior. What do you figure that means? It's inheritance. That's exactly what it is. So this is something called a mono behavior. Okay, now let's not worry about what that means, but that is the general, again, this is the way they're steering you. You don't have to build all your code as mono behaviors. As you get more advanced, you probably won't. You'll probably have some normal classes that don't inherit from mono behavior, and you may end up with some static objects as well. I think that's actually a really nice way of organizing things in Unity, but this is the approved way. Okay, again, not that the other way is unapproved, but they're steering you this way. Okay, so when you're a mono behavior, you inherit certain types of certain stuff. We could go online and look and see exactly what that is by looking in the API documentation. But one of those things is that you're signed up to receive callbacks, right? So again, this callback model that just seems to just be getting more important every year, right? You're going to write some functions that you never invoke. They're invoked by the system. So now it's incumbent on you to understand what is the exact name of the function? What are the exact arguments, if any, that it needs? Do you need to return something specific? What's the signature? Okay? All of those things you've seen before, and they're in full force here. Okay, now you see they're just empty here. Start is a thing that typically happens one time when a level is loaded or when a theme is initiated. Again, I don't know that you've created anything with more than one scene yet, but probably by the end of the course you will be creating things with multiple scenes. So in that case, that if this code exists in both scenes, that start function will get called however many times you do a load scene. Okay, but for us right now, we just do one at a time. It's once. And then update, on the other hand, is what's called every single time a frame is going to be created and rendered. Okay, so that's usually where most of the heavy lifting is done, and certainly the real simulation over time is done. Okay, what else do I need to say about this? Let me check my cheater notes here. Yeah, okay. So, yeah, again, one of the things that would have been news to you a quarter ago, but you're very familiar with now, is this distinction between classes and objects. Well, I guess it exists even in JavaScript, but this is really a model that's very close to Java. Just because you have a class doesn't mean you have any object. There's also a tiny bit of object hierarchy that I think everybody should know. There's a whole lot of classes out there. If you want to become an expert, there's a lot to learn. But there's a little bit. That's a little bit of a tree there. Okay, where there's a kind of a generic class called object at the root. This is very normal. Okay, I think it exists even in JavaScript these days, that there is a base class called object, even though you might not never realize that it's there. Okay. And then it has two important children. The top one is game object. That's all of your 3D assets. Pretty much everything that you're going to go and populate your screen in is going to be a game object. But to make game objects do anything in Unity, we end up adding a bunch of components to them. Right? So component, in the sense of a class diagram, a component is a sibling of game object. It also inherits directly from object. Okay, and again, I'm trusting that you know, okay, this is a class diagram. The way it's actually instantiated when we actually build objects, class diagrams build no objects. When we build objects, we're going to build a game object that will own a whole bunch of components, typically. That's the typical way. Now, under components, there's a couple things that are really important. One is the ubiquitous transform. Every game object that's created always has at least one component, which is a transform. Okay, but then you may also have mono behaviors. Okay, again, there's a behavior class that's kind of a parent of mono behavior. I don't even know what's in that class. I've never touched it directly. But mono behavior, again, is going to be your typical script. All right. All right. So I think that's good to get started. Let's actually look at the script that was on the sphere, and I'll come back to this in a little bit. It's mostly just stuff I want to make sure I say before we're done. All right, so this is the script that's actually on the sphere. So let's take a look. Okay, and the first thing we see is awake. Public, private, void, awake. So what the heck is that? Okay. By the way, I think it's the same in Java. These don't say private, void, but they're private. Private's the default. Unless you make it public, protected is something I don't use very much. Unless you make it something other than private, it's private. So those are all private functions. What's this awake thing? All right, good moment to maybe realize that this all this documentation over here, which again is very... sorry, but this is the best system that's out there in terms of documentation, and the documentation is still very uneven. Some things you will just see wonderful documentation for exactly what you need. Sometimes it'll be a brief paragraph that really is kind of useless if you actually want to do something with the object or with the concept. Okay, you will see both plenty of times. Okay, now this awake, startup, update, these are event functions. Okay, so you can see some general description over here of event functions, what they are, blah, blah, blah. But the thing I really want to show you, because this is the kind of thing I pop up routinely myself, is this nice thing. Order of execution for event functions, right? So functions are callbacks, right? So callbacks, so wouldn't it be nice to know? So first we just saw setup, an update, then this awake thing showed up. Like, are there any more? What are the callbacks that are provided in the Unity system? Okay, here's a diagram. See all these things? It's probably not all of them. Okay? So by being a mono behavior, you're signed up for getting called back if you implement those functions. If you don't, no harm, no foul. It's fine. It will just go on its merry way. There's probably some default implementation that's sitting in mono behavior or somewhere else that does nothing or does just routine stuff, and you can just ignore it. But you could also implement any one of these things. Okay, now what's the structure of this diagram? Okay, first thing to say is it loops around, right? You look down to the bottom, goes all the way to the bottom, then back to the top, because it's thinking of a mode where it's thinking of a game. But simulations these days work the same way. Well, how does a game work? The user goes, they take Mario comes in from the left, jump, 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 collect a bunch of coins, get to the end, you win, okay, and the game's not over. It then loads in level 2, and you start again, okay? Thus the circular nature, right? And we might be doing the same thing. We're in scenario 1, you get to the end of that, you're not done with your training, now scenario 2, okay? All right. So these things up here happen just once per level load, once per scene load. Awake, oh yeah, there it is, right there. Okay, and also some other stuff. On enable, I don't even know what that is. I have to look at documentation. Reset, never used it. Start, very typically used. Okay? The reason I'll use both awake and start is because, and this is the use of this diagram, as you see, awake is called before start. Okay, this helps a lot. So the Unity uses this new model of like semi-graphical programming that just kind of magically, it makes the programming seem a lot easier, I think. You've been through the tutorials, right? I mean, it's not mind-blowing, right? You're always just writing these little snippets of code that are attached to these objects. But the problem happens when now you've got a lot of those objects around. You've written a lot of snippets of code, and you're going and stuff's not happening in the right order. You need object 1 to be updated before object 2. Well, how do you arrange object 1's update to be called before object 2's update? Answer, there's no way to do that. Okay? That's on the system. It will decide what order. Okay? You don't like it? Too bad for you. Okay? Now, what you could do, though, is you could look and see, I need object 1 to have this thing happen before object 2. Now, this wouldn't be a per frame thing. Okay, if it's just in the startup of a scene, then perfect. Okay, object 1 I will implement awake, and object 2 I will implement start. And now I'm guaranteed that object 1's thing is going to happen before object 2. All right? Okay, same story as we go down here. Now this inner loop with these hard black arrows coming back, this is the stuff that happens every frame. Actually, let's skip that for the moment and just go down to the bottom. Okay, actually this is the end of the every frame thing. These things down here also happen just once per scene. And this on application quit, on disable, on destroy, just because there might be certain things that need to be cleaned up. You might need some special stuff to happen. You want to be able to display the user's current score, whatever. You might just want to implement these to do some stuff that just happens one time at the very end of a scene. All right? And then in the middle is all this stuff that happens each and every update. So how often is that? Well, probably at least 30 times a second, something like that, maybe more. Okay. Well, actually, it depends, because there's actually a physics update, okay, and a graphics update. So this stuff on the upper loop, this tight loop right here, this happens every physics update. Well, what's physics update and graphics? What is this? Okay, physics updates happen much more frequently, typically, than graphics updates. So one of the things that you hopefully picked up from our first go-round with physics and simulation is that long times are very dangerous in physics simulations. If you go do that approximate, figure out like, okay, you look at the derivatives at the current value, and then you just say, well, I hope it stays about the same because that's what my algorithm is assuming it's just going to kind of take that slope, it takes the amount of time, and it estimates what the change is. Okay, as that time gets big, our assumption that that rate of change is going to stay the same over that interval gets more and more shaky. Okay? So the way to combat that is to make sure the physics gets updated on a tighter schedule than the graphics. So in other words, we care a lot actually about having the graphics get updated well, because when it doesn't, the system looks like it's chugging, there can be flickering, there can be all kinds of visual artifacts. Your users will not be happy if that outer loop isn't good. But much worse when objects just decide to, remember the spring kind of going off to infinity, right? When objects just decide to blow up and disappear. Much worse. Okay? So the priority is on the physics. All these functions happen every fixed update. So the idea with physics is, so how do they decide how often to update physics? They really decide, they pick a very small interval of time, and they say, that's the most we want to go, that's safe to go, and we need to update physics at the end of that time. So it's a fixed interval. Unlike the graphics update, which they do as fast as they can, all things considered, okay, but it's not at all fixed. We just, as soon as we're done with the last one, however much time that is, we go and start rendering the next frame. That's not a fixed update. Okay, that's the idea. So all of this happens in the physics update, and then all the stuff below the physics update, but before this other arrow looping back, have to do with the graphics update. Here's where we see the regular update call, okay, and all kinds of other stuff. In all honesty, almost all of which I've never touched. Stuff that's very specific to animation, this is all kinds of special purpose things. You can imagine that they probably don't like having so many different calls that they have to implement and deal with in their engine. So probably each one of these, there's an answer. If you're like, well, why do you need a special callback for that? There probably is an answer to that, but I can't give you that answer. Okay, in most cases. Sometimes I can guess. All right, any questions about this? Okay, you've seen where it is. It's right there in the manual. Order of execution for event functions. You should be able to find it when you need it, because you might need it. All right. Good. So now you know what awake is. It's something that happens before start, and it happens one time when a scene is loaded. All right, let's see what happens in this particular behavior. Actually, let's start off before. So what you see right here are the properties of the object. Would you assume these are private properties or public properties?
Private.
They're private because you're not explicitly saying they're public, so they're private. Okay, again, protected. Another thing, when you're starting to build object hierarchies, you can worry about that. I don't do that typically. All right, then we come into this awake. Again, this is going to happen first, not because it's before start in the file, but because of that order of event function execution that I showed you before. Okay, you see what happens here. Debug log, everyone know what debug log does? I don't actually know. Do they do that at all in the tutorials? That's the way you write to the console. So that's your console write. So again, you know I love my console writing, okay, and pretty much everyone does because it's just a very good tool, easy to understand, so there you go. So that in awake that we saw in the console, it came from this line right here, debug.log. Now you will see, if you're looking online, it'll probably happen to you at some point, because none of us are experts in C#, that you're Googling and someone has some code and you cut and you paste, and the way they try to write to the console is system.write. Okay, that is a way that works in probably 99% of C# applications that are out there that are not Unity related, but in Unity it needs to be debug.log. That's the way it is. Okay, so you just need to change that and it should work for you. All right, so that's that. The next thing we do is, you see I have an M_Q is the name of a game object there. Okay, now what I'm demonstrating is, so this is the next big topic. So again, it's so nice to be able to break up the code and put a little bit on every object where you need it. Okay, but what about when the code on this object has something to do with some other object? How do you deal with that? Now you have the problem. If you'd just written it in a conventional language, it would all be there, and you just grab the other variable and off you'd go. Okay, but now you can't, so how do you get around that? Okay, there's a bunch of ways. Okay, here is how you get a handle on a game object using its name. Okay, that cube is actually called cube in my scene. Let me prove it to you. There it is. It's called cube right there. That's how I'm grabbing it. Okay, there are other ways to get objects. You can ask for them by, do you realize every object has a tag over here? That's possible. You can ask for all objects of a particular tab. Now, objects are also on layers, so you could probably ask for them by layers. I've never done that, but I'll bet you can do that. Okay, all right, so this is just one good pattern to use. You see, it's some kind of a static method on the game object class. We just say game object, find, give the name, and here we get our object. All right, now I have the object. What do I have what did I want the object for? Well, this is just demonstration. Yeah, Barrett?
So if I use the tag function to select some object,
yes,
then every object with this tag.
Yes, and it will turn back an array of game objects. That function. Yeah.
Sure, thanks, sir.
Yeah. Okay. Now, let's go to the next function that gets called, start. What do we say? Debug log in start, yeah, because I just wanted to show you, no kidding, awake really does happen before start. Let's look. Awake is here, start is here. Look at the timestamps. Actually, they're the same timestamp because it happens so fast. But if it's a tie, in terms of seconds, it's then the one that happened before does come second. So, all right, so that's legit. All right. What do we have here? A nice little comment. Game object, note the lowercase g, okay? That's not the class name game object, uppercase g. It's just it's basically behaves like a keyword in the Unity implementation of C#. Is the game object that owns the current script. So that, again, this is a handy way. Same issue. We're executing a script. We're in a component that's attached to a game object. How do we get up and grab our game object, right? Well, we need to move. The script's purpose is to move the game object. Well, we've got to get it first, right? It doesn't come without any doing, okay? But they did make it very easy. If you just use lowercase g game object, that means my game object. I'm some code. I'm in a component. This is my game object. Okay? If you write some code that's not attached to any component, you will have a problem with this. It won't be defined. It'll throw up on you. Okay, now the next thing is I want to move the game object. Okay, now I think there is an easier way to do this, I think. Well, we'll demonstrate that first, but I just want to show the generic way of now I have the game object. Let's say I need a component that's on that game object. So it's the same problem when, I'm writing a script, I'm inside a game object, the other component could be sitting right next to me in the inspector, but you can't access it from the code unless you actually go and ask for a handle to it. Okay, how do you do that? Okay, this is the invocation. Okay, game object, so my game object, dot get component. Notice the angled brackets, so that's the way they do generic stuff. Did you do generic collections at all with Java, like a list that can handle more than one type, or maybe you didn't get that far? Okay, well that's the idea, So if you didn't get that far, then you might be wondering. And back in the old days, it really was like this. If you want to write a linked list of integers, okay, I code that up. Oh, but now I need a linked list of floats. Well, you got to cut and paste that code and do a whole other thing and change all the ints to float, and then when you say, oh, I need another one for doubles. Oh, there you go. Strings. Oh, okay, yet another one. Okay. No, I need one for some special object that I just created. Oh, okay. All right, there's no end to it. Okay. This was a huge waste of time. Okay, so what was invented was a way to make classes that are parameterized. Okay, where you can say it's a list, angled brackets of integers, a list, angled brackets of floats, and you write your list code one time. Now the cost of this is a little bit of weird notation. That's what these angled brackets are going to be. Maybe the code looks a little bit like 10%. It's not a lot. A little bit more arcane, a little bit harder to read. but not much. But we can write it one time and then just have one linked list that we can put any kind of object in we want. Same thing here. This is the way you go to the game object, give me the component, but there's a lot of components, right? So you ask for it by type. It's the transform component. Let's go to our cube and see. You probably don't need to see this, but let's look anyway. Okay, I've selected the cube. You see here are the transforms and here are their types. Actually, yeah, mesh filter I think is the type for this. And when you actually go for this, you probably have to take the space out. So this is not a perfect system. You may be flailing around the first couple times to get the syntax exactly right before it gives you the thing back, but I think it's pretty easy. This one's box collider, this one's mesh render. I think it's just a matter of taking the spaces out, and up here is my transform. Okay, so that's the idea. Now, I think there is an easier way to do this, okay? I think that... But I could be wrong. Okay, let's just understand the code the way it is, and then I'll do my risky stuff that might break it. Okay, good. So now we have a handle to the transform. What did I want it for? Just to do some printing. So here you go. I, the sphere, am at my transform. Transforms have inside them a property called position. Position is a vector that has a property that has an x, a y, and a z, and that's how we reported the position of the cube. Let's go check it out. Wait a minute, it was on the sphere. That runs on the sphere. So we reported the sphere's position first. Here it is. I, the sphere, am at 0, 0, 0. Let's see. Okay, here's the sphere. Oh yeah, position 0, 0, 0. It reported it correctly. Okay. Now the next thing I do is just show that okay, it's not just my own object. I, a script. I'm a component. I'm sitting on a game object. I can not just access my own game object, I can just as well access any other game object. That's the next thing that's demonstrated here. Okay, remember over here we grabbed a reference to the cube. Okay, and now I'm able to do that. I'm able to use that to get the cube's transform. Again, same invocation, get component, blah, blah, transform, and then report the cube's position. Again, it said the cube was at 2, 3, 5. Let's see. Okay, there it is, 2, 3, 5. Okay, all good. Now I think so now we're almost to the bottom. Let me be patient. Okay, and then this thing is going to get called once per frame. What's it do? It basically just prints a message to the default. We're in the update. The update function's happening. The update function's happening. The update function's happening. It does it up to 5 times, and then it says, or 4 times maybe, and then says that's enough because otherwise it would be just doing it forever and ever and ever. Okay, and in fact we can see down here in update, there it is, happened 5 times. All right, now the next thing, didn't like something about okay, not really sure what those warnings are, don't like that. Okay, let's go back to the code here. Now I think this is the way you do it. You do get component with angled braces and the type of the component in almost every case, but there might be a shortcut that works for transforms. I certainly know that for my own transform, so like right here, I don't think I have to get it at all. I think I can just do transform and it should work. Let's try it just on this first thing. Let's see, if it even accepts it, it's probably good. So, right? So, let's see if it still works. It's building my code. It's going to clear when I run, and we'll see what the new result is. Okay, go back out, go back in. Okay, boom. Okay, it ran. Okay, so yeah. So for transforms, it's this is very special. This is just like the game object thing. And there's like almost nothing else that's like that in Unity. Everything else, you're going to have to use this invocation to get the component. That's why I'm demonstrating. Okay? Now on other objects, I think we can maybe do mcube, that's a game object, dot transform instead of getting the component. Again, just because transforms is a special thing. But I could be wrong with this. Let's not believe it until we see it works. Okay, it's mcube dot transform dot position, maybe. Yeah, it looks like that's going to work. Okay, it's done. We run. Work perfectly. Okay. All right. All right, let me back those changes out, get back to where we were. All right. Okay, any other questions about this? All right, so that should get you started. That's the scripting. Now, the next thing we want to talk about, we're not going to get too far, so there goes my hopes of quickly getting through. Actually, since we have spent this much time, let me just go through and make sure there's not other stuff. Yeah, the other things I think will come up in due course. Okay, so let's go on to the next example. Okay, so there's a scene here called input and instantiation. Let's see what this thing is about. So you double click over there, and then you press play. You can see the first of the scenes that's going to have some physics in it. Okay, now this looks really boring, but if you press the space bar, it gets slightly less boring, because it will spawn in the cube that you see drop to the ground under the control of physics. And you're not limited to one. No, you can have as many as you want. Okay. Okay. What do you think is happening? Look at that swaying tower. Okay. When I bring in the next cube, what do you think is going to happen? It's going to want to come in right where that last one was. What's going to happen? Yeah, they're both going to go flying. What's going to happen is it's going to come into being. The collision detection is going to go, oh my God, we have a terrible problem. Objects should never be intersecting one another. It's going to apply possibly massive forces, though it's a lot smarter than physics used to be. The objects just don't literally disappear, but they will blow out pretty fast. Like, there you go. One got thrown up in the air, the other one got bumped enough that it fell down, and there you go. Okay? Keep going. You see if they can fall off the edge, and gravity just takes them right down. Okay, so this will provide us with entertainment for a while. Okay, let's try to understand that. Okay, let's get out.
I just can't stop.
Yeah, physics is pretty great. Okay, let's start talking about physics. All right, so one thing is there must be a script here somewhere, and where is it? Okay, it's actually on the plane. So you can see spawn cube script is a component of the plane. So if I go over here and say edit script, it should pop this up, and you see, where's all the code? For such cool behavior, there should be a ton of code, right? Well, no, because that's one of the things. That's one of the things Unity has done the best at in terms of is making the workflow as light as possible for routine uses of physics. Now, once you go one step beyond what's routine and what what everyone has done 100 times in games, now good luck. Now you have to actually know a little bit about how physics works and what the issues are. It's all there in the library. You can probably do what you want, but you're going to work a lot harder. All right, so let's look at this spawn cube. And the first thing I want to say about it is, okay, public transform cube prefab. First of all, what's transform? Does anyone remember?
XYZ.
What's that?
The position of the cube, XYZ.
Right. Okay. And transforms can be used as a surrogate for game objects. I'm not sure why it actually works that way. That does genuinely seem magical. And that's pretty typical. It's pretty much, I think in the tutorials, did you see that? Like if you want to be able to, well, I'll show you. Next thing is public. So what's going to happen with a public variable on a mono behavior script like this? What's the magical thing about that? Anything occur to you?
It appears on the Unity side.
It appears in the inspector, okay? And you can edit it graphically, okay? Including drag and drop and all kinds of other cool things, okay? So that's that. So let's actually take a look. Public transform cube prefab. All right, fine. Let's take a look. Here's my script. Okay, here's my cube prefab thing, and you see it has a transform has been assigned to it. Okay. Now, where does that transform come from? Well, that transform is what's being used to create, as we'll see in a minute, it's what's being used to create all those cubes. So the way you actually get prep to do something like this is you build the thing you want to spawn, you get it looking, sized, everything just the way you want it, okay? And then you drag it down into your asset window down here, again, into your, what do they call this? The project window, your palette, where it will become a prefab. So in our case down here, this is my physics cube right here, my prefab. Okay, that is what actually is assigned. And then what you can do is you can just, to actually do the assigning, you can click here and just drag it right over onto the window, and boom, there it goes. Okay? So that's where that came from. Okay, now we should, this is why I say, I'd like to go, we need to go over the surface, we need to do that so you can kind of see the lay of the land, but then we also need to dig in a little bit. Maybe we'll dig into this next time or the time after. We still have some lecture hours left, but not sure we'll get there today. Let's see. Okay, let's look at the rest of the code. Okay, nothing happens in start. You could just take that out. There's no need to have that there. It's probably there because I was using it before, or just because, as you saw, that gets created when you create a mono behavior script. All right, update. All right, the first interesting thing is, how does the system actually know that I pressed the space bar? It's really kind of interesting. Okay, so this is very old school in a way. Right? Actually, the JavaScript what we were doing is more the new style. If you remember what we had to do to detect a key press or a mouse click, we had to have an event function, a callback, and we said we had to register our callback. We say, hey, if any mouse clicks happen, you need to call this function here, and then whenever a mouse click happened, our function got called. Okay, here, this is what's called a polled system. So it's polling. What does polling mean? It means that the code has to explicitly check for the event to happen. Okay? So once a frame, okay, not exactly when you press the button, but in the next frame, when the next update happens, here's the polling. We go, there's an input class and a static method on it called getKeyDown, and we say, okay, here's the key we need. Okay, it's a key code object dot space is the way to say the space bar key, and there's a way to say every key on the keyboard. Okay, that's how we check to see if the space was pressed. If it was pressed, that returns true. Otherwise, it's going to be false. Okay, that's the first thing. That's kind of interesting. The next thing is, how do we actually make the cube pop up? Well, here it is. Real easy. You just say instantiate cube prefab. Cube prefab, remember, is the name for whatever we loaded in up there. Okay, and that's all we need to create a new object. All right, so good. Okay, so let's push forward a little bit. I think we have time to look a little bit further. Okay, let's look at the next one. It's we're not done. I won't leave it there. We need to make at least another pass through and try to go dig a little deeper and mess with stuff a little more. Whatever I fail to mess with, you should definitely mess with on your own until you're happy. But let's look at scene 3 briefly. Okay, triggers and destruction. All right, let's press play. And this is actually set up similar to the other one, except you see there's a semi-transparent cylinder there. Okay, that is being used as a trigger volume. Now, I think you encountered trigger volumes. Do you encounter them in the tutorial that we're doing? Did they never use trigger volumes?
Yes.
Okay, I think maybe way at the beginning, the ones that run automatically, we have the little guy moving through and he has to get to a certain location. The trigger volumes must have been in there, but I don't know I don't remember if they're actually calling them out and saying, oh, here's the trigger volume and here's how it works. Maybe not, because they're so introductory. Okay? Now, the idea is that any block, it's actually the same application as before otherwise, but any block that enters, that sets off the trigger, gets annihilated. So if you see there's a block, boop, it's gone. Block, it's gone. Block, 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 block. Okay? If it goes and hits the trigger, it's gone. Now, if you make them so that they fall outside the trigger, no, they're fine. They're just on the ground as normal, but anything that hits the trigger is gone. Okay, so what we'd like to understand from this is, okay, what's this trigger volume thing? How do you set it up? How do you make the blocks go away when you're done with them? That's all goodness that we'd like to get out of this example. Okay. All right, so let's take a look. Let's first find our, okay, so first thing is, let's go back on the plane. We have that spawn cube script. Let's see if it's the same or if anything's changed. Looks the same. Spawn cube has just been copied over from the last scene. Cool, so we don't need to look at that. But the cylinder has this trigger script on it. Okay, let's take a look. Okay, now, you see that this cylinder. Okay, let's go to the plane. Let's create another cylinder just so we can do a comparison test here. Let's go and say game object, 3D object. Let's create a new cylinder. There it is. Okay, here's a normal cylinder. Look what it has in it when it's born. There's a transform. It's got the cylinder mesh. It's got a special component that knows how to render the mesh so you can actually see it. Okay. And it has a collider on it, okay? The collider is there so that if something bumps into it, we can have a chance of not going through it. But typically, that's what you want on a game in a game situation, okay? That's what we have there. Now let's compare that to this other cylinder, and you see, okay, it's almost the same, but okay, the collider down here, you see it says is trigger, and it's blank, but the one up here says is trigger, and it's checked. Okay, that's what lets it actually act like a trigger. Okay, act like a trigger means what? Destroys objects that touch it? No, not at all. It just means that there's another callback that will get generated when that thing is clicked. Where's the code? Okay, see down here? We have a script down here. It could be called whatever you want. It doesn't have to be called trigger. Okay, let's open it up and see what's in there. Okay, not a lot. But here's the thing. So on trigger enter, that's the key event function that you need to implement if you want to know when an object has entered you. And by the way, there are a bunch of rules. Not just any object intersecting with the trigger is going to set it off. It needs to be a kind of a physics type object of its own. There's actually in the manual, there's a nice little table that says what kind of objects will set off triggers and other ones. So if you're in this, you're beating your brains out because it's like, it's a trigger and I wrote the script and nothing's happening. Okay, probably the object that's coming in is not of the right type. So be sure it's configured properly. Okay, on trigger enter. Now notice the signature for this thing. Unlike every other event function, this one you actually have to have an argument to this function. It's of type collider. Okay, and then other, it doesn't need to be called other, that's just my name. It will, but whatever you put there, that name will get bound to whatever it is that's entered your trigger zone. Okay, now what you do with it is totally up to you. Okay, in my case, I want to destroy that other, so there we go. Destroy, I can't just say other, because other is a collider. You don't destroy colliders, but you destroy the game object. So from other, I can ask for its game object. Again, remember, that's very special. It's one of those very special lengths. But it's nice that you just say the word destroy. Instantiate, it comes in. Destroy, it goes away. They made it as easy as they could. All right? So that's that. Right? Also maybe deserves a little bit of playing around with. Don't save. Okay. I'm going to use every minute I have here, and we still won't get to the end. All right? But I'm trying to do what I said. Okay, crosshairs and camera rays. Okay, so you'll find this interesting. So this will advance us along the path toward a FPS shooter type thing, which was the default thing that you guys will be doing for the project. Okay, so there's some geometry there. There's a character motion model, so WASD. It's got, you can jump. It's that same motion model that we brought in before. Okay, and the thing is, you see that bit of dirt in the middle of the screen? And it's actually not dirt, but that's my crosshair, right? Okay, so if you point to something and left click, you see that red sphere moves to the location of the intersection of our eyeball shot through the screen on the same line. Whatever it hits, it gets that location and moves the sphere there. See that? Put it up there. Put it up there. Put it right next to you. Put it over there. All right. Okay. So you see, if you can understand this, you're going to be sitting pretty good to do basic shooter functionality the simple way we do it in most things, and probably including in BBS3. Is there a bullet drop? There probably is for the official BBS3. There probably is actual. So the shooting probably is not on a straight line. But for most games, the action occurs so up close in your face because you want to see the things you're shooting at. There's negligible bullet drop anyway. Okay, so you might as well say that the line is straight, and that's what people do. Okay, so we're out of time, so that's where we'll leave it for today. We almost did what I said and did a fast once over the top. Then we'll dig in more, and this stuff will be in the assignment for a week from Friday. Okay, good? Excellent. Let's